Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Find the derivative of the following. Y equals cos inverse of 1 minus x square divided by 1 plus x square, right? So whenever you see these type of problems, right, I think you should immediately try and draw a parallel to one of the trigonometric identities that we know. And in this particular case, we have a cos inverse and we have a 1 minus x square divided by 1 plus x square, right? So what is that substitution that will enable me to bring this particular expression inside the cos inverse in the form of cos, right? And similarly, whenever you have a sine inverse expression, you will have to think about what is that substitution that I can make that will enable the expression inside sine inverse to take a sine format, right? And similarly, tan inverse and so on, right? So, for example, in this particular problem, right, if I do the substitution x equals tan theta, I'm going to just pick out the inner expression and let me call it, say, g. Okay. And then when I do the substitution x equals tan theta, let's go to the next step. I have my g in terms of theta now, and instead of x, I have tan, right? And instead of x square, I have a tan square theta. Now we will end up with an expression whose identity we are quite familiar with, right? For example, 1 minus tan square theta divided by 1 plus tan square theta is nothing but cos 2 theta, right? Why is that? Because my 1 minus tan square is nothing but 1 minus sine square by cos square, the whole divided by 1 plus sine square by cos square. And when you do a cross multiplication and rearrange the terms, you will be left with a cos square theta minus sine square theta, which is nothing but a cos 2 theta. And it's very important that you remember this identity because it comes in very handy, right, in many of these problems. So I have my g equals cos theta. So I go back to my y. My y becomes cos inverse of cos 2 theta. And what is cos inverse of cos 2 theta is nothing but 2 theta, right? Right. So that's my y, but my y is in terms of theta, and I've been asked to find dy by dx. So let's start off with dy by dx equals 2 times d by dx of theta, which is nothing but d theta by dx, right? And where do I go for my d theta by dx, right? So my d theta by dx is nothing but, I go back to this original substitution. Let me highlight it. Maybe I'll use a green color. So this is my x equals tan theta. I go to the next step and I differentiate on either side, right? So my d by dx of x equals 1. And then my d by dx of tan theta, I apply the chain rule. The outer function is nothing but a secant square theta. And my inner function here is theta. And I'll have to differentiate it with respect to x, right? So I will end up with a secant square theta d theta by dx on my right hand side of this particular equation, right? So I have a secant square theta into d theta by dx, right? And which means my d theta by dx, I'm putting it in the same line, is equal to 1 divided by secant square theta, which is nothing but a cos square theta. So we have the answer for my d theta by dx, right? So I use this particular d theta by dx. Let me highlight it in a different color, say yellow. And my dy by dx is nothing but 2 times d theta by dx, which means I have this as 2 cos square theta, and I know that my final answer has to be in the form of x. So my 2 cos square theta is nothing but 2 divided by secant square theta. Let's write that out. And what is my secant square theta? My secant square theta is nothing but 1 plus tan square theta, right? So I have more or less arrived at the answer for dy by dx. So my dy by dx is equal to 2 divided by 1 plus tan square theta, which is nothing but 2 divided by 1 plus x square. So there we have our final answer. Let me highlight this in pink. Yeah, so dy by dx equal to 2 divided by 1 plus x square, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.